continue 9.5 part 2. And we're just going to start off with expanding again. So let's go ahead and expand this. We need Pascal's triangle, right? So I'm going to go ahead and draw that out. And we're going to be using this one because we have to the third power. So I'm going to go ahead and write 1. I'm going to actually write this down here so I get some more space. So 1 plus 3 plus 3, and then finally plus 1. Okay, so now what you're going to do is this is your A and this is your B. So you're going to take negative 2x, raise it to the third power, and then negative 2h, raise it to the 0 power. Now decrease the A, so I'm going to do that first. And then that would just be 0. Okay, then increase the B. Okay, and then now we're just going to go ahead and simplify this. So this gives you negative 2 to the third, that's negative 8, and then x to the third, and then that whole thing just becomes 0. Okay, then we have negative 2 squared, which is 4 times the negative 2, and then times the 3 in the front. So that gives us negative 24. And then as far as the variables, we get x squared and h. Okay, then the next one, I have 3 times negative 2, which is negative 6, times negative 2 squared, which is 4, so that's negative 24 again. And then x h squared. Okay, then the last one is going to be negative 8 h to the third. Okay, so notice that they're all negative, right? And that's because both your A and B is negative. And you could, if you wanted to, you could factor out a negative out of this. We're going to expand this one. I already know from the previous one that this is going to be 1 plus 3 plus 3 plus 1. And so you're going to get x to the third, and then that raised to the first. And I'm going to decrease the x's first. Then I'm going to do negative 3y to the fourth to the first, negative 3y to the fourth to the second, and negative 3y to the fourth to the third. And we're just going to keep on expanding this. So x to the third, and then here we have negative 9 x squared plus y to the fourth. And this one is going to give you 3 times 9, which is 27, x y to the eighth plus negative 27 y to the 12th. Okay, so that would be our answer. Okay, so we're going to go ahead and do this one without a calculator. We're going to compute 11 to the fourth. What you want to do is you want to rewrite it as 10 plus your remainder, which would be 1 in this case, and then raise it to the fourth power like up here. So we're going to use a binomial theorem where A is 10 and then B is 1, and this is to the fourth power. So I kind of have those memorized already, so that's 4, 4, 6, 4, and 1. So this would be 10 to the fourth times 1 to the 0. Okay, and then this next one is going to be 10 to the third, 10 squared, 10, and then finally 10 to the 0. So this would be 1 squared, 1 to the 3rd, times 1 to the 4th. Alright, and then figuring that out, this is going to give me 10,000. And then this next one is going to give me 4,000. Plus this next one is going to give me 600. Plus 40 plus 1. So that means this is going to be this number. And so this would be useful if you didn't have a calculator, or you didn't have access to a calculator at a certain time, then you would use this. Okay, so next we have an imaginary number, and we're going to go ahead and expand it again using the same. We're going to use the tree, so I'm going to go ahead and draw it out. Alright, so we're going to go ahead and use that last row. So I'm going to go ahead and write it over here. So 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. And this will be our A, and then this will be our B. Okay, so we're going to do A first. So 1 to the 6th, and then 1 to the 5th, 1 to the 4th, and etc., etc. So I don't actually need to write those because that's just going to give me 1. Okay, then the next one is going to be 2i to the 0, then 2i to the 1, 2i squared, 2i to the 3rd, 2i to the 4th, 2i to the 5th, and 2i to the 6th. So this is going to give me 1. Then this is going to give me 12i. Then this is going to give me 4 times 15, which is, 4 times 15, which is 60 I squared, plus 20 times 8, 160 I to the 3rd. Then this one is going to be 15 times 2 to the 4th, which is 240 I to the 4th, plus 2 raised to the 5th times 6, 192 I to the 5th, plus 2 raised to the 6th, which is 64 I to the 6th. Okay, now you want to go ahead and simplify these. So remember, I is just I squared is 1, negative 1, sorry. I to the 3rd is negative I, and I to the 4th is 1. Okay, so we're going to use that to simplify this. So 1 plus 12i. This one gives us negative 60. This one gives us negative 160i plus 240. And then this one would be 5. If I simplify that, that just becomes I. So that's plus 192i. And then I to the 6th, well, if I do that on the side, if I divide that by 4, the remainder is 2. So it would be this one. So it would be a negative 1. So it would be minus 64. Okay, then we're going to go ahead. Alright, so when we add 1, negative 60, 240, and negative 64, we get 117. And then when we add the rest of them, we get plus 44i. So whenever you're solving anything with I, you need to make sure that you leave it in standard form, which is a plus bi. So you really want to make sure that you put the real part. Alright, what we're going to do here is we're going to find the case term. So we want to find the sixth term of an expansion of 3x minus 2y to the 11th. And we're going to recall that we could actually expand that, and then you could count all the way to the sixth term. But why would you do that when we have a formula? So our formula is going to be n choose k, a raised to the n minus k, and then b raised to the k power. Alright, so we need to find what k is. So here it says find the sixth term, but we're dealing with k plus 1 in this case. So in reality, it's going to be 5 plus 1 equals the sixth term. So our k is 5. Okay, now we could plug it in, and then n is just what your number is raised to. So 11 choose 5. 3x raised to the 11 minus 5, which is 6, and then negative 2y raised to the 5th power. Okay, so you could do 11 choose 5 in your calculator, and we're going to get 462. Then we have 3 raised to the 6. So I'm going to go ahead and do that on my calculator. And we get 729 times x to the 6th, and then negative 2 raised to the 5th power, which is negative 32 y to the 5th. So now I'm going to go ahead and multiply those numbers. And that would be our number here. So this is our answer.